Download this code from codegive.com, link in the description below. OK, let's dive into the dreaded bad request error, HTTP 400, and how to diagnose and fix it. This is a common error that can be frustrating, but understanding its causes and how to troubleshoot it will make you a much better web developer. What is a bad request error, HTTP 400? The HTTP 400 bad request error is a client-side error. It indicates that the server received a request from the client, your browser, an application, etc., that it couldn't understand or process due to a problem with the request itself. Think of it like trying to give someone instructions in a language they don't understand, or giving them instructions that are contradictory or incomplete. The server simply cannot fulfill the request as it was submitted. Key causes of bad request errors *. Here's a breakdown of the most common reasons you might encounter a 400 bad request error, along with explanations and code examples. 1. Syntax errors in the request *. Malformed URLs *. The URL you're using might have incorrect syntax, invalid characters, or encoding problems. This is a very common cause. Invalid request headers *. The headers sent with the request might have incorrect values, missing required fields, or be formatted improperly. Malformed request body, data. If you're sending data, example in a post request, the data itself might be malformed. This is especially true for JSON, XML, or other structured data formats. 2. Invalid or missing parameters *. Required parameters missing *. The API or web application you're interacting with might require certain parameters in the query string, part of the URL after the, or in the request body. If these are missing, the server will reject the request. Invalid parameter values *. The parameters you're providing might have values that are outside the expected range or of the wrong data type. For instance, a parameter that should be an integer is being sent as a string. 3. Cookie issues *. Corrupted cookies *. Cookies stored in your browser can become corrupted or invalid. This can cause issues when the server relies on those cookies for authentication or session management. Oversized cookies *. Cookies have size limits. If a cookie becomes too large, it can lead to a bad request error. Incorrect cookie domain or path *. The domain or path set for a cookie may not match the URL of the request, causing the cookie to be rejected. 4. Browser caching issues *. Stale cached data *. Sometimes, the browser caches an old version of a request or a response, and when it tries to reuse it, it causes a conflict with the server. 5. Large request size *. Exceeding server limits *. Web servers and APIs often have limits on the size of requests they will accept. If the request, including headers and body, exceeds this limit, you'll get a 400 error. This is common when uploading large files. 6. Server-side validation errors, that manifest as 400. Input validation *. While technically a server-side issue, a 400 error can arise when the server's input validation fails. For example, you might be submitting a form with a field that doesn't match the expected pattern, example an invalid email address. Business logic failures *. In some cases, the server might reject the request because it violates some business rule, example trying to create a duplicate record. Although this could be a 400, it's often better represented with a 409, conflict, or a more specific error code. 7. Encoding issues *. Incorrect encoding *. If the data you are sending is not encoded correctly, example using the wrong character encoding, the server might not be able to interpret it properly. UTF-8 is generally recommended. Asterisk URL encoding problems. Asterisk special characters in URLs, example spaces, and need to be properly URL encoded, example spaces become %20. Failure to do so can cause a bad request. 8 timeouts. Asterisk request timeout. Client side. The client might give up waiting for a response and prematurely close the connection. This can sometimes manifest as a 400, especially if the server was in the middle of processing the request. Troubleshooting and debugging steps. Here's a step-by-step guide to help you diagnose and fix bad request errors. 1. Inspect the URL. Carefully examine the URL. Look for typos, missing slashes, incorrect parameter names, and unencoded special characters. Use a URL validator. Online tools can help you verify that your URL is properly formatted. Example. 2. Check request headers. Use your browser's developer tools. Press F12 in Chrome, Firefox, or Edge. Go to the Network tab, find the request that's failing, and examine the headers section. Look for content type. Is it correct for the type of data you're sending? Example: application/JSON, application/XWWW formerly encoded. Authorization. If you're using authentication, example API keys, OAuth tokens, is the header present and correctly formatted? Content length. If you're sending data, does the content length match the actual size of the data? Any custom headers, check if they are properly formatted. Example, Python using the requests library. 3. Inspect the request body, data. Examine the data you're sending. Is it in the correct format, example valid JSON, XML? Are all required fields present? Are the data types correct? Use a validator. For JSON, use a JSON validator. For XML, use an XML validator. Example, JSON validation. 4. Check cookies. Inspect cookies using your browser's developer tools. Application-cookies. See if any cookies are expired, corrupted, or have incorrect domain/path settings. Clear cookies. Try clearing the cookies for the specific domain you're interacting with. Example, setting and clearing cookies in JavaScript. 5. Clear browser cache. Clear your browser's cache. This forces the browser to fetch fresh data from the server. Try a hard refresh. Ctrl+Shift+R or CMD+Shift+R. This bypasses the cache completely. 6. Check request size. If you're uploading files or sending large amounts of data. Check if the request size exceeds the server's limits. The server's documentation or administrator should have this information. Implement pagination or chunking. If you're dealing with large data sets, break them into smaller chunks to avoid exceeding size limits. 7. Examine server logs. If you have access to the server logs. They can provide valuable information about why the request was rejected. Look for error messages, stack traces, or other clues related to the bad request. Common log locations. Apache /var/log/apache2/error.log or /var/log/httpd/error_log. *inks /var/log/inks/error.log. 8. Use a network sniffer, Wireshark, Fiddler. Asterisk for advanced debugging. Asterisk a network sniffer captures the raw HTTP traffic between the client and the server. This allows you to inspect the full request and response, including headers, body, and any other data being exchanged. Asterisk useful for asterisk identifying subtle encoding issues, header formatting problems, or unexpected data being sent. 9. Simplify the request. Asterisk reduce the complexity of the request. Remove optional parameters, simplify the data being sent, or try a minimal working example to isolate the problem. Test with a simple client. Use tools like curl or Postman to send a simplified request to the server and see if it works. This helps determine if the issue is with your code or with the server. 10. Consult API documentation. Review the API documentation carefully. Make sure you understand the required parameters, data formats, and authentication methods. The documentation often provides examples and explanations that can help you avoid common mistakes. Code examples, illustrative. Here are some code examples that demonstrate how to avoid common bad request errors in different programming languages. Python, using requests. JavaScript, using fetch. PHP, using curl. General best practices to avoid bad request errors. Validate input on both the client and server. Client-side validation provides immediate feedback to the user, while server-side validation is essential for security and data integrity. Use a well-defined API schema, example OpenAPI/Swagger. This helps ensure that the client and server are communicating with a shared understanding of the API's structure. Handle errors gracefully. Provide informative error messages to the user or log them for debugging. Keep your libraries and frameworks up to date. Security vulnerabilities and bugs in older versions can sometimes lead to unexpected errors. Test thoroughly. Write unit tests and integration tests to verify that your code is sending valid requests and handling responses correctly. Use a tool like Postman or Insomnia for API testing. These tools allow you to easily construct and send requests to your API, inspect the responses, and debug any issues. By systematically following these steps, you can effectively diagnose and resolve bad request errors, ensuring a smoother and more reliable experience for your users. Good luck.